Good afternoon. I'm Marc Overhage, and this work was conducted with my colleagues Stephen Bandeian, Gautam Rao, and Sean Granis. I'm going to describe TAXIS, an effort to turn observational OMOP common data model data into computable clinical knowledge. The long-term goal is to support computable biomedical knowledge that can be represented, exchanged, reasoned over, reviewed, and reused. The motivation for TAXIS is that many health informatics tasks depend on the same underlying clinical knowledge: phenotype development, cohort construction, episode grouping, care pathway analysis, clinical decision support, and even retrieval augmented generation for LLMs all require some understanding of how clinical concepts relate to one another. Today, that knowledge is often built and rebuilt one project at a time. Odyssey phenotypes, for example, often start with manual curation of related diagnosis and other concepts. And there have been efforts such as the Odyssey Phenotype Library that help, but variable maintenance, project-specific variations, and lack of awareness limit the reuse. The pipeline is built on the Odyssey infrastructure, including the OMOP CDM and vocabularies. And TAXIS first starts with the OMOP concepts as they appear in a large observational data sources, such as the Indiana Network for Patient Care. Second, it identifies observed concept pairs across clinical domains, so drugs and conditions or devices and drugs that are found to co-occur. Third, it applies screening signals such as lift, semantic distance, and temporal ordering to narrow down candidates. And then applies large language models under structured constraints to classify the relationship type and direction between pairs of clinical concepts. The output is a candidate knowledge graph artifact with relationship metadata and validation evidence. The current INPC-derived graph is only a beginning, but it already has substantial scale. It's based on data from about 2.2 million persons. It includes almost 96,000 distinct concepts, 24 different pair types: drug, condition, condition, device, and 14.2 million observed concept pairs. It's worth noting that these 14.2 million observed pairs are only about 0.9% of the roughly 1.5 billion theoretically possible concept combinations from those 96,000 concepts. So the real world co-occurrence already substantially narrows the candidate space even before statistical screening or LLM review. The next iteration of Knowledge Graph will use the full INPC database of more than 20 million patients, and at least two other large OMOP CDM instances are planned to follow. This slide shows some of our initial external validation results, specifically using a 3,000 almost pair set of validation set that was created as part of the ClinVec project. And in the first graph on the left, you'll see the lift scores for the physician scored ratings of how pairs compared. In the center panel, LLM relationship classification, binary classification of that based upon the physician classification. On the right, the results from the ClinVec study, which was just looking at cosine similarity between pairs, how they co-located in space. So the estimated precision is about 65%, and the F1 score is 34.3%. So sensitivity is not great, 23% or so, and is an area that we have substantial work to do. So I interpret this that it's a useful early validation profile. TAXIS appears well suited at this point to surfacing a subset of likely meaningful relationships for review than it is to replace comprehensive knowledge curation. And I'll close with a provocative question. The next step is not only to build bigger, better graphs. The more interesting question is how a versioned, validated clinical relationship graph can be used to create and maintain computable biomedical knowledge. One way to think about this is that in a graph native model, many computable knowledge artifacts become versioned, reviewable queries over that graph. That's the potential that TAXIS offers. moving from observational data and AI-assisted relationship classification to reusable graph substrates for computable knowledge. Thanks for your attention, and I am looking forward to the rest of the presentations.